today's topic is components of time series. In the previous video, we have already discussed how to check the stationarity in between the values or the data points of a particular variable. In time series analysis, that variable or the values of the data points of a particular variable contains some components also, and today we are going to discuss those components and how to visualize those components in R. There are various components. The first one, trend or long-term movement. It implies the general tendency of the data to increase or decrease during a long period of time. Periodic changes or the short-term fluctuation. Periodic changes in time series analysis refer to repeating or recurrent pattern or fluctuation in data. It happens due to some forces at work which prevent the smooth flow of the series. Such forces may be classified as seasonal variation, cyclic variation. In seasonal variation, it happens due to the rhythmic forces which operate in a regular or periodic manner over a span of less than a year. For example, monthly, weekly, hourly, etc. Now the cyclic variation. The oscillatory movements in a time series within a period of oscillation more than a year are termed as cyclic variation. For example, business cycle. And the third one is random or irregular movement. It refers a non-recurring and irregular circumstance which are beyond the control of human hand but at the same time are part of our system, such as earthquakes, wars, floods, revolution, etc. Each and every time series data is a function of these mentioned components, and this functional form can be decomposed by various models such as additive model, multiplicative model, or mixed model. Here we have considered the additive model where yt is equal to t plus s plus c plus r, where small yt represents the time series value at time t, p represents trend, s represents seasonal variation, and c represents the cyclic variation, and r represents the random fluctuation at time t. And this additive model assures that all four components of the time series operate independently of each other so that none of these components has any effect on remaining three. Now, in R script, here we have already import our data file. Now select and run. This is our data file. These are the values of maximum temperature monthly wise from January to December from 2000 to 2022. Now go to our script. At first we are going to draw a time series plot of maximum temperature. Type a variable name. Yes, this is the functional form of time series. We need our interested variable is maximum temperature from the data. It has started from 2000 January month and end 2022 December month, and frequency is equal to 12 because our data set is a monthly data. Now again select and run. This is our data set from January to December from 2000 to 2022. Now we are going to draw the plot, auto plot of MP. For that we need a library FPP2 temperature plus CG title. time series plot of temperature plus y left temperature. Run. This is our time series plot. Zoom. This is our time series plot. These are the values of temperature and this is time. Now go to our script and we are going to decompose this time series plot into various components. For that we need a library seasonal. Name variable decom. Functional form is decompose. Now plot decom. Control run. Error in couldn't find a function decompose. Small letter decompose MP. Then again select and run. And this is our decomposed time series data or decomposition of additive time series, where this is the observed data and this is our trend and this is our seasonal variation and this is random fluctuation or movement of the time series data. By this way, we can decompose our time series data into various components. Thank you so much for watching this video. If you like this video, please subscribe our channel and see you in the next video.